Hey there, and welcome to Into the Terminal, episode 43. Today we're going to be talking about performance profiles with TuneD. Scott, take us away.
Thanks, Eric. All right, so let's get started with TuneD, which is a method through which we create kernel tuning and system tuning parameters and then have it persist between reboots. So TuneD started being part of the standard Red Hat Enterprise Linux install with RHEL 7. So if we just take a quick look at systemctl status for the TuneD daemon, we should see that it is installed and running. So great. The next thing we need to do is the way that TuneD operates is through profiles. Profiles are simply a named list of tuning parameters that should be applied to a system. So if we do a TuneD ADM active, that will show us what our active profile is. So this machine is running the virtual guest profile, which is, which is not surprising considering that it is a cloud instance, which would be considered a virtual guest machine. We can get a list of all of the profiles available to us with TuneD ADM list. And so each of them has a description or a profile name, and then a brief description that goes with it about what it's for. So you can see virtual guest down there towards the bottom. Also, you can see that TuneD ADM list gives you the currently active profile in its output as well. So we probably could have skipped that TuneD ADM active command if we just wanted to see what was available. All right, to change the active profile, what we could do is a TuneD ADM profile, and then the name of the profile that we want. So let's do network latency. Network latency. All right, so what we just did was we went through and made a bunch of tuning changes to the system to optimize it for having low latency networking. So it went through and tuned some networking proc tunables and some other stuff. And we'll take a look at that after the break. All right. To find out more about installing additional pre-made tuning profiles that don't come natively with TuneD but might be provided with an additional package, if we do a DNF list available star TuneD star. So these are ones that Red Hat provides as part of our list of available TuneD profiles. So there's one for MS SQL, Oracle, Spectrum Scale, RHEL Atomic, which that's interesting. Maybe it's not RHEL Atomic. Maybe it's something else that's Atomic Updates. But so if we were to install these packages, we'd get some extra TuneD profiles that might be interesting to us for something like Microsoft SQL Server. Right. So after we install this, if we just do a list again, we got an error.
Well, that's fine.
SSL certs. Let's try downloading it. Let's try installing it one more time. Okay.
Hey, what do you know?
And now, if we do the list, you could see there in the middle is the MS SQL profile. That's what we got when we installed that additional RPM. All right. So after transition, we're going to take a deeper look at some of these things. What's to come is what exactly is in a TuneD profile, right? So we said we changed the profiles, it changed tunables, but how can we see what those are and what is it doing? And then also how to create your own TuneD profile that might be with your specific updates that you want to make to how your system is operating.
Performance is one of the most painful things to troubleshoot and adjust, but TuneD profiles really makes it much, much easier. So I'm really glad you all joined us for Into the Terminal episode 43, talking about TuneD profiles, how to adjust your performance. So there's one other command before we start talking about building out our own profile that I wanted to cover. So if we jump back into the terminal here, there at the top of the show, we actually we actually changed our active profile to network latency. But TuneD actually gives us the option um, to get recommendations from the system. So if you do a TuneD, a Tune ADM recommend, Tune.
You're right. It was
It helps if you.
TuneD ADM.
I said it right. I typed it wrong. Doing great. There you go. So because this is a virtual system, it's going to pretty much always default to virtual guest as the recommendation. So always take those recommendations with a grain of salt.
Also, one of the things that we didn't take a look at before the transition, Eric, we changed the active profile. And it turns out that that active profile is stored in a configuration file, which is etc tuned active underscore profile. Right? So we changed it to network latency, which persists it in this file. And that's actually what's used at boot time to determine what profile should be assigned to the machine when it boots. So this configuration file, etc tuned active profile, is the configuration thing that keeps the profile settings assigned consistently between boots on the system.
Awesome. So this is the part of the show where you can jump in on chat, or if you're catching this after the fact, you can put in your questions into the comments below. So with that said, feel free to throw your questions into chat. And so Scott, why don't you tell us a little bit about why TuneD was developed and kind of what the purpose behind that is?
Yeah. So one thing is that what you change in your tunables depends, right? Historically, what we used were like the syscontrol settings, which are the in-memory tunables for the kernel stored under the procsys directory. But because they're in-memory tunables, that means when we shut down the machine, they were lost, and when they booted up the machine, they were set back to their original values. So we had this thing called syscontrol, which would run at boot time to reapply those changes. But over time, we also got tunable parameters for things like disk elevators or huge pages or some other parameters on the system that were outside of the procsys directory structure. And so TuneD was a method through which we can have a central place to store all of our tuning parameters for our system that will take care of adjusting things in procsys or things in /sys or other places on the machine to account for those tuning changes we want to apply. Plus, it runs as a daemon, and we can group the tunings together into what we call profiles. And starting with RHEL 7, I think, profiles can also include other profiles. So it used to be that you had to define everything from scratch if you were making your own. But starting in RHEL 7 and later, you can say, oh, I like the throughput performance profile, so I'll include all the changes for that one and only change these other few things on top of it, right? So we have this kind of like library of tuning that we can leverage through TuneD that previously we just had to kind of know what to do and do. So Eric, you want to take a look at what's in a TuneD profile?
Yeah, let's do it. That sounds like fun.
All right. So when we do the RPM, we get a bunch of them out of the box, right? So if we did an RPM-QL, so query for a list of files that come with the TuneD package, this is all that you get when you install TuneD. But notice that there's a bunch of them under user lib TuneD. And then like it's implemented through Python, so we see the Python stuff up higher. So why don't we take a look at user lib TuneD throughput performance.
Let's see. You said throughput.
Yep, throughput. You need an extra slash there. And each of the TuneD profiles has a tuned.conf file. So let's just do like a cat or less on that. Okay. So starting at the top, so the main has the summary. That's what displayed to us in the TuneD ADM list of profiles. There are a couple of variables that get defined, so you can actually set variables in your TuneD profiles. We have CPU tools. So for this system, or for throughput performance, we set the power governor to performance, which is like, I don't care about my power usage, use it all. And that is a setting that is outside of the traditional Proxys tunables, right? Then we can see that there's a provisional thing for if we are using Marvell ThunderX CPUs. There's actually some changes that are made because of that choice of CPU, like we should never have transparent huge pages available for it. The next section is disk. So these are the changes we will make to the disk subsystem. And for throughput performance, we want to set the read ahead value to about 4K. So whenever we do a disk read, we're going to read the next 4K of that disk as well, with the expectation that just because we asked for a piece of data, we probably need the next component piece of data as well. And then under the syscontrol header here, this is where our traditional proc-sys changes come into play. So we can see that we're changing the VM dirty ratio parameter, dirty background ratio parameter, and sloppiness on our system and the kernel parameters. All right, and then again, if we're using Marvell ThunderX, there were a couple other things that got changed, like the kernel NUMA balancing syscontrol parameter gets changed. And here they do a little bit different arrangement. So it's not bundled into the rest of our syscontrols because it only applies to this specific CPU type. So inside this little section, we have that it's a syscontrol type tuning change, that we are looking for something in the uname output to indicate that we should match this section. And then further in the CPU info output, there's this regular expression string. So if we're both at AARH64 and we see the ThunderX CPU info regex variable that we defined up earlier, then we will apply this kernel NUMA balancing parameter. Otherwise, we would skip applying it. So that's a little bit on like what actually gets defined inside of one of these TuneD profiles. One other one that we might want to take a look at, and we can use less for this one because we'll be interested in the top part of it, is userlib TuneD virtual guest. And that was our default one and our recommended one on this system. And so this is one where we base this TuneD profile off of another one. So include says I want to include all the tuning changes from this other TuneD profile. So this one's based on throughput performance. And then in addition to sucking in all the stuff off of throughput performance, we should make the following additional changes. So in throughput performance, I think they set the dirty ratio to 40, and we're remapping it for virtual guest to 30. And then in throughput performance, we set the sloppiness to 10. But here in virtual machine guest world, we should set that to 30. Right? So we overrode some of the throughput performance ones with our own. And if there were any additional things that we needed to do specifically for our virtual guests, we could add them in here as well.
So imagine when you're building a TuneD profile and you're using the include. I assume that the parent profile is what value is used. So like you mentioned, dirty ratio and throughput performance was set to 40, whereas in this profile it's set to 30. So I assume that the parent profile would take would assume any conflicts.
The opposite. So oftentimes in Unix and Linux, whatever is done last sticks. So we pull in all the throughput performance stuff, and then we overwrite pieces of it with our parameters here in virtual guest. And because the virtual guest ones were applied last, they're the ones that stick around in the system.
Yeah, so child, not parent. You can tell I'm still on cold meds.
Glad you're feeling better, though.
I'm getting there. Definitely getting there.
All right, I see.
Anyway, I'd love to build our own.
Okay, let's do it. So the ones down in user lib TuneD, those are provided by the TuneD RPM, which means if you mess around with them, then if you apply an update to the TuneD RPM, you have a potential to have your changes unmade or replaced, right? So we don't want to mess around with the ones down in user lib TuneD. Instead, what we're going to do is we're going to create a directory in etc TuneD, and we call it whatever we want our profile name to be, right? So we're making one called Awesome VertDB Profile.
We're nothing if not descriptive on Into the Terminal.
And then inside of this profile that we just made, we're going to have to create a TuneD.conf. All right, and then inside of our TuneD.conf, we have several sections that we're interested in. We'll have the main, which is where we define if we're including anything from a previous TuneD profile. So here we're including virtual guest, and we're going to make some changes on top of virtual guest. And then we also included a summary, and that's so if we do a list, a TuneD ADM list, we'll see ours and this summary string. Okay, now hang on for a second, Eric, because I don't want to do all the things at once. We need to like dribble it out. All right. So we'll do this this disk section. So what we're saying here is what all the SD type devices to have an elevator, right? A disk scheduler set to MQ deadline. I'll talk about that in a second. And then actually, you know what? Let's go ahead and put in the rest of it too. We'll put in some syscontrols. I thought I was being more fancy than I was, but we need to take off that bit in parentheses. So when we were setting up our show notes, I put these bits in parentheses so we could see what it originally was, and we can compare it with what it gets set to. So I chose these syscontrols very specifically because a couple of episodes ago, we talked about installing and managing database servers. And these were the settings that we applied to our database server that we set up. And I said in that episode, like we were doing it manually by setting the syscontrols in RAM. And I said, oh, one day we'll get to TuneD and we'll make these permanent. Well, today's that day. We're doing TuneD and making them permanent. All right, so let's go ahead and save this. But before we apply it, let's take a look at a couple of these parameters, right? So maybe we take a look at procsys VM swappiness. Oh, it's already set to 10. So let's set our profile back to virtual guest.
Oh, that's right. Yeah, we changed it.
Yeah, we changed it to network latency. Okay, so let's take a look at swappiness one more time. All right, so it's set to 30 because that's what the virtual guest swappiness says. Let's also take a look at /sys /block /SDA /scheduler. No. Sorry, /Q /scheduler. So these are the available disk schedulers for our kernel. Rightly so, on a virtual guest, we want it to be set to none, which it is. But for the purposes of monkeying around with our TuneD, we had said that we wanted to set that to MQ deadline, right? So after we move to our new profile, which if you do a TuneD ADM list, Eric, we should see our new profile there. All right, there's awesome VertDB profile. So after we move to this profile, what we should see is things like swappiness and dirty ratio and some of that stuff changes in compliance with our new profile. And then also we should see that switch in scheduler for our disk. So why don't we go ahead and apply that change?
Let's see. Oh no, autocomplete doesn't work on that. Awesome.
It doesn't. That's a surprise when you cleared off the list, the TuneD ADM list, because that would have been really handy.
Yeah, I could have just copy paste.
All right. So let's take a look again at the swappiness value. So now we expect it to be 10.
I just completely
VM.
blanked. VM.
VM swappiness, yep.
There it is. Hey.
Cool. So that was set. And then if we take a look at, and probably recall it from history,
You know what? That's a great
/sys block. Yeah, there you go. So before we made this change to this new profile, it was set to none, and now it's been switched to MQ deadline. And Eric, when you come back from almost dying, you can do a quick cat on Etsy TuneD active profile. Right. So thanks to this being changed in the active profile, if we were to reboot this machine, actually, you know what? Let's reboot the machine. What could possibly go wrong? It should come back and be applied again.
So one thing about TuneD that I was kind of surprised by when we wrote the episode guide was that you don't have to do anything to get the profile to show up. A lot of services require you to do like a reload on the daemon or some kind of or like like Nginx, you have to do a reload on the daemon. Other things, you have to actually restart the entire service. But TuneD, we wrote our we wrote our profile, saved the config, and it showed up on our list. So we didn't actually have to do anything to get that to show up.
Yeah, and actually, it's because TuneD ADM actually looks at all of the configuration files and stuff live. So when you run the command, it's actually doing all the work then. It's not working off of a cached copy. All right, so let's see what our TuneD ADM active is. See?
Yay!
Persisted across reboot. Yeah. So real quick, Eric, to show that we're actually reading all those directories and everything live, why don't you move that Etsy TuneD awesome VertDB profile tuned.conf and call it something like tuned.cfg. And then do your TuneD ADM list. So remember last time it showed up in the list? Now it's not there anymore because when it did the live read on the directory structure, it didn't find a file called tuned.conf and then read all the data out of it to show in this listing. Right. So yeah, it does everything live every time.
Although it still has our profile settings loaded.
Yes, because that was applied and that was updated that configuration file, the active profile. But if we were to reboot the machine now, things would not be so great because it wouldn't be able to find that active profile in order to reestablish it. I actually don't know what would happen, but probably don't want to go there. So why don't
we don't have
2D
console
CFG
access to
back?
this. Probably kernel panic and just never come back alive.
I don't know that would be the case. I think maybe like the TuneD daemon would barf up an error or something and would continue, but we'd be running with no tuned parameters, maybe. Yeah. So why don't we go ahead and move that file back so that we don't break ourselves by accident one day.
You know what?
Oh, we should probably go in there and make sure that that instead of MQ deadline, we switch it back to none, because none is the appropriate setting for that for a virtual machine. And I don't want people to think that they should always set MQ deadline or something. All right. All right. So I see Shantanu asked us a question.
Yeah. So first question was, why did the regex thing work? And I think that was in reference to the TuneD.conf file that we wrote. Is there any specific syntax for if else? Sounds like Ansible stands a territory.
So TuneD is not Ansible-y. It is its own syntax, and they included regular expression interpretation inside of it. So I don't think that you want it, like, while it feels automation-y, I don't think you actually want to try and tackle that on your own. The reason that the regex thing worked was because inside of that stanza for Marvel X Thunder CPUs, we had two criteria that it had to meet. And that's a much more advanced method of using TuneD, because you're making a very specific conditional stanza. But the plus side is that you could then take that and like blast it out across your population of boxes. And on boxes where it's not appropriate, it wouldn't be applied, right? And on boxes where it is appropriate, it would be applied. So it's another method through which you could create a bit of customization that you can tactically apply when it makes sense for the system hardware. I think Shantanu had also asked about where he could go for more information. So we actually have a performance management and tuning guide for RHEL. They started publishing it in 7, but it had a slightly different title. And then 8 and 9 have the same title. And not only does it cover kind of the introductory how to use TuneD that we started with the show with, but it also goes through a little bit on making your own profile and has some examples. And that's a totally gnarly URL, but it takes you to the place where you get getting started with TuneD.
And then I'd also recommend they're out on Enable Sysadmin. There's a really good blog post that was written about Linux TuneD tuning profiles. A little bit quicker look at different profiles and what they mean, and kind of a rehash of what we went through today. Both of those links will be in the show notes. That's kind of all the questions we had. Scott, any closing thoughts on that?
Just one, which is when you're doing performance tuning, realize that you are optimizing your machine to do a specific workload better. And that means that it's going to be doing other workloads potentially worse. So, like when we did the vert guest, right? I said we should appropriately set our disk elevator, our disk scheduler to none. And the reason for that is because your virtual machine has a hypervisor underneath that actually does all the I/O queuing for the disks and stuff. So if you at the virtual machine layer doing deadline scheduling and reordering what IOs are happening based off of that scheduler, and then it goes to the hypervisor who then reorders everything based off of those things at the hypervisor, you're doing the same work twice for no gain, right? In fact, you're doing extra work and then having it undone on the other side at the hypervisor side. So we set it to none, not because we don't necessarily want to have disk IO management, but more that at a virtual machine level, we can't really do disk IO management because the hypervisor is going to do it anyway. So, it's those types of thoughts that you have to think when doing performance tuning, which sometimes can be hard, especially when you're in a complex environment, or using things like NAS arrays. Like NASs also have their own disk scheduling stuff. So if you order it all on your hypervisor or your virtual machine, and then you send it over to the NAS, which then reorders it anyway, like why are you even bothering to put it together in the first place? So those are some thoughts to think when doing performance tuning.
And Shantanu had a follow-up comment. So by learning, I meant a software which learns to profile your current running workload to create a profile for you. So that's starting to sound like AI type stuff.
Yeah, and again, because the tuning is a very challenging thing to do. And when we're like making changes and we are going to gauge whether those changes are successful or not, really success generally looks like a 1 to 3% improvement, right? Which in the grand scheme of things doesn't sound very successful. But the Linux kernel is done by a whole bunch of smart people, and they kind of know what they're doing for most things. So when we're making these tuning optimizations, we're trying to just wring that like extra bit out of our machines that we couldn't get otherwise. And so like, I don't even know that an AI/ML model would be able to recognize that 1 to 3% is less than noise, right? So yeah, as far as I know, no, there's nothing that does that currently. Instead, we look at factors like what the BIOS is. Right, that's how we actually notified that this machine was a virtual guest, was because we looked at the BIOS information and it said like GCP. And they're like, oh, cloud instance, virtual guest. If you look and see your actual hardware, then it would probably choose something different. Like throughput performance is generally the one that gets picked. So yeah, like it's kind of where we're at in terms of how we make those guesses for the default TuneD parameter or TuneD profile.
Awesome. That's kind of all the questions we had. So to wrap up, this has been a look at TuneD profiles and kind of wringing that extra little bit of performance out of your systems. Join us again. Excuse me. Next week, we'll be talking. We'll be going back to networking world. We'll be talking about network bonding and configs with Red Hat Enterprise Linux 9. Oh goodness, gotta love changing seasons. With Red Hat Enterprise Linux 9, there was some changes made to the networking stack and to bonding and teams. So definitely join us next week. We'll do kind of an overview of what bonded NICs are, network configs, and we'll discuss the changes between RHEL 8 and kind of before, and then what's changed in RHEL 9. So definitely don't want to miss that. If you missed it this week, we had an awesome episode on RHEL Presents of satellite and smart management. And then here in 2 weeks, there's Ansible Fest. So lots going on around our neighborhood. So bridge networking for VMs. Yeah, sure. We can look into adding that.
We will try. However, when we originally were discussing the content for that episode, it's more about the like local system configuration, right? So like if your VM or your host was defining an IP address, like what does that look like?
Right.
Yeah, the other is going to be. We'll see. We'll take it under advisement, Shantanu. Thank you.
All right, folks. Well, thank you so much for joining us, either live or after the fact. If you liked the content, be sure to give us a thumbs up and share it with a friend. Be sure to hit that subscribe button so you know every time we're live. So on behalf of my co-host, Scott McBrien, and the entire Red Hat Enterprise Linux team, really thank you for joining us, and we'll see you again next time. Bye-bye.